Okay, today we're going to be looking at our last lesson going towards the Unit 8 test. Just a little sidetrack piece of information on Unit 8. We're spending a little bit of time combining terms and doing distribution, which is another way of combining terms. Actually, Unit 8 actually has us factoring terms as well. But when I kind of flipped through the tests, before the unit even started, just to get an idea what all's in the unit, there weren't any questions at all on factoring. So I didn't really notice that factoring was in Unit 8. But honestly, I don't see any reason for us to spend a whole bunch of time doing factoring that's not going to be on this test. So what we're going to do is we're going to go ahead and take the Unit 8 test. Then we will kind of backtrack a little bit and do the factoring stuff. And then I will invent an additional Unit 8 test that'll kind of look at the factoring stuff that the C-scope test didn't. Okay, but we'll get into all that starting next week. So today we're going to be looking at combining like terms in rational expressions. That's not terribly different from what we did yesterday. The only difference is today we will be finishing off the actual steps when we end up with 2 fractions in our answer or 3 fractions in our answer, however many fractions there are. We're going to actually find the common denominators, and we are going to combine those all the way into 1 fraction. So review. Everybody should know this. We can only add or subtract fractions when. What must fractions have in order to be able to add or subtract them? Got to have common denominators, okay? Remember, with multiplication and division, fractions don't care if they have common denominators or not. You can, with multiplication, you just multiply straight across. Division, you can leave, change, flip. But when it comes down to adding or subtracting, you absolutely have to have common denominators in order to combine them, okay? There's just no way to get around it. As we're going to see today, as we've been seeing for the last week and a half, we're going to have variables floating around in these fractions. Okay, so when it comes down to finding the common denominators, it's possible that our denominators might have variables in them. We'll learn to deal with that. Okay, our numerators might have variables in them. We'll learn to deal with that. Variables are just values. Okay, they're just numbers. We just don't know what numbers they are. We gotta deal with the problems, even though there's variables in them. Okay, so let's take a look at a problem. Okay, here we have a rational expression, 1 fraction being added to another fraction. In order for us to be able to finish this problem off, we are going to need to figure out what the common denominators will be. Now, mostly I think people are generally okay, even though they may be a little bit shaky, with finding common denominators when there's numbers involved. Okay, but for some reason we kind of throw up a little bit of a mental block and say, you know what, it's just too difficult when there's variables involved. It's no more difficult when there's variables involved. We just have to figure out what the variable or what the denominator can become. Okay. Now think about when you were doing common denominators if you just had fractions with numbers in the denominator. When finding a common denominator, what did that actually mean? We were trying to look at like 2 fractions, look at the denominators for both fractions and figure out what number can I increase these both to become so that I can like multiply one denominator times a number and the other denominator times a number, and then in the end those denominators both become the same number, right? That's kind of what finding common denominators was about when we were dealing with numbers. Okay, well, variables are no different. Okay, we just have to figure out, I need to multiply this denominator on the left by something and multiply the denominator on the right by something. And in the process of doing this multiplication, this new denominator that's going to show up in both fractions should be the same in both places. Okay, well, look at what we've got going on here. Right now, we've got one denominator that's got an A in it, one denominator that's got a B in it. Now, we're not going to do anything fancy or crazy or anything like taking this A away from this denominator on the left or taking away this B from this denominator on the right. But we got to increase both sides to become something. Well, this denominator has an A, but it's going to need a B if it's going to become common, right? Okay. And this denominator on the left, it's got a b, but it's going to need an a in order to become common. So what we're looking at here is if one denominator's got an a and the other one's got a b, then the common denominator most likely is ab. Okay, it's ab. At this point, your question kind of becomes, all right, if my fraction on the left needs a b in the denominator, okay, I'm going to multiply a new b into my denominator on the left. But the rule with fractions is anything that you do to the denominator of the fraction, you also have to do the exact same thing to the numerator of the fraction, right? You can multiply the denominator by anything you want, but you got to multiply the numerator by the exact same thing to keep the fraction true. Okay, so our fraction on the left, we're going to multiply this denominator by b. Okay, which means we're also going to have to multiply the numerator by b. The denominator on the right, okay, what's it missing? It's missing the a. So we're going to multiply the denominator on the right by a, and whatever we do to the denominator, we have to do to the numerator also. Okay, so there it is, multiplying by b over b on the left, and multiplying by a over a on the right. Now, doesn't it seem like this would mess up the fractions? That we've taken these things, we've multiplied the denominator by something, multiplied the numerator by something. Doesn't it seem like that would change the overall value of the fraction? Okay. If you're thinking that, I honestly don't blame you. But let's think about why you can actually do this. What's b divided by b? It's what, right? Because you got b divided by b. That's law 2 of the laws of exponents, which says to take the numerator's exponent and subtract the denominator's exponent. So you got b to the first minus b to the first. 1 minus 1 is 0. What's anything to the 0 power? It's 1. Okay, so b over b is 1. A over a is 1. Can we take a fraction and multiply it by 1 without changing it? Sure. Okay, that's how come we can get away with multiplying a denominator by any value we make up. As long as we multiply the numerator by the exact same thing, all we're really doing is multiplying the whole fraction by 1. It's just a different looking 1. Okay, well, let's look here. Back to the problem. In this little multiplication here on the left, we got a times b in the denominator. That's going to be ab. Denominator on the right, b times a. That's going to be ab. Is that going to get us our common denominator? Yeah, it's going to be the same in both cases. Now, guys, whatever happens to the numerator, it happens. Okay, it's not a big deal. We're focused on the denominator, making the denominators common. Okay, so in the numerator here on the left, you got a d, you got a k, you got a b. Okay, there's nothing in common there. They're not going to combine in any ways. They're just gonna kind of join together. Numerator on the right, you got an R, you got an A. Again, R's and A's they're not combining. They're just going to kind of join together and stand there side by side. Okay, so there you have it. Now this is, kind of a little bit where we got stuck yesterday. I mean, obviously we weren't finding the common denominator yesterday, but we ended up with 2, and sometimes 3, and sometimes 4 different fractions. Now we're going to actually combine them into one fraction. Once the denominators are the same, there's no reason to write these ratios separate from each other. We're going to put them all together in one ratio. The denominator is going to be AB. What's going to happen up top? This BDK, whatever it is going to add together with whatever AR is. Just write them down. Okay. Now, obviously, it's not always this abstract. You don't always have this many variables running around in the problems. Okay, but it's pretty normal to have maybe a coefficient or two. Okay, you're going to have some numbers in it, and maybe a variable or two as well. But it all works the same way, following the same steps. So let's take a look at some more. Okay, a little bit simpler of a problem. Not quite so many variables running around in it. But we have a fraction being added or subtracted to another fraction. It's a rational expression. In order for these two ratios to be combined into one ratio, we're going to have to find common denominator. Okay, so have a look. What do you think the common denominator is going to be? Yeah. This fraction has a 4. This one doesn't, but it's going to need one, isn't it? This one's left one on the left's got it. The one on the right doesn't. Okay, so we're going to have to give a 4 to the denominator on the right. Okay, denominator on the right has a b. The one on the left does not. So we're going to have to give the one on the left a b. Okay, so some of you were saying it. What's the common denominator going to be? 4b. Okay, so one has a 4, the other has a b, so it looks like 4b would be a good denominator. As we just said, we're going to give whatever's missing from our common denominator, we're going to give it to each fraction. This denominator on the left, the 4, it was missing the b, so we're going to give it the b. But whatever we do to the denominator of a fraction, we got to do to the numerator of the fraction to keep it true. Fraction on the right, it's got the b, but it didn't have the 4. So we're going to give it the 4. Whatever we do to the denominator, we've got to do to the numerator to keep the fraction true. Okay. All right, what's our new numerator going to be on the left? 3b. Denominator under it will be 4b. Okay, what's the numerator on the right? Not 6. 2 times 4, 8. And underneath 4b. Okay, denominators are common. Now, double check it before you go adding stuff up. Make sure you actually did get the common denominator. Sometimes we get a little sidetracked. We think we got the common denominator. We know what we're after, but then we do something that doesn't get us the common denominator. So double check right here. Make sure you do have your common denominators. We do. There's no need for these to be one fraction anymore, so it's joining together to become one fraction. 4b will be in the numerator. What will the numerator be? 3b minus 8. Now, before you leave these problems alone, okay, once you get it down into one fraction, double check it one last time to make sure nothing will reduce. Okay, now when it comes down to problems like this, like in the numerator, we have a binomial. There's 2 terms up there. Denominator, we have a monomial, 1 term. The only way anything will reduce from the numerator to the denominator is if you can get the exact same thing from all the terms in the numerator and all the terms in the denominator at the same time. So there's 3 terms to look at: the 3b, the negative 8, and the 4b. Those 3 terms, do they have any one thing in common that we can steal from all 3 of them at the same time? The 3b's got a b. The 4b's got a b. I can cancel it if I can get a b from the negative 8. Does the negative 8 have a b to give up? It doesn't. Okay, so you can't cancel that b. Don't make the mistake of saying, oh, I got b over b. I'll let law 2 take care of those for me. Because if you can't get it out of all 3 terms at the same time, it's not going anywhere. Okay, same thing. There's a 3 in this term. There's a negative 8 in this term. There's a 4 in that term. Is there any one number that we can take away from a 3 and an 8 and a 4 all at the same time? Do they have any factors in common, a 3 and an 8 and a 4? No, there's no one number that we can get out of all 3 of them at once. So that's as far as it goes. Okay, always double check that. Make sure there's nothing that'll reduce. And remember, you just got to get it from all of your terms at exactly the same time. If you can't get it from all of them, then you can't get it from any of them. This doesn't change matters if they happen to give us problems that have more than 2 terms. There's just more to do. Okay, so here we have one, a ratio 4 over b being added to another ratio 1 over c, then the subtraction of another ratio 1/2. Okay, well, same idea, same questions. A common denominator. We need a common denominator that can come for these 3 terms. What do you think? Okay. Seems pretty clear. We're going to need a b, we're going to need a c, and we're going to need a 2. Okay, so how about just simple enough, just 2bc? Okay, it's like 2bc would be a good denominator. All right, so y'all help me out here before we uncover it. What am I going to have to multiply the first ratio by so that we can get this new denominator? What's it missing? It's missing the number. Okay, so we're going to have to hit it with a 2. What else are we going to have to hit it with? The C, right? It's got the B, but it's missing the 2 and the C. So the first ratio is going to get multiplied by 2C and also the numerator by 2C. Okay, look at the middle. Okay, the middle ratio there. What's it going to get multiplied by? The 2. What else? And the B, right? It's got the C, but it doesn't have the 2 or the B. Okay, so we're going to multiply by 2B and also multiply by 2B in the numerator. Okay, how about the last ratio? What's it need to be multiplied by? Yeah, it's got the 2, but it's missing the B and the C. So we're going to multiply by BC, and we'll also multiply the numerator by that as well. And if you kind of identify that all in one step, that's okay. I mean, that's not taking too many steps at once, okay? Because we're kind of doing the exact same thing to each of the ratios, but we're doing it in a way that each ratio is getting what it needs. So the first ratio needed the 2C, the second ratio needed the 2B, and the last ratio needed the BC. Okay, looking pretty quickly at it across there, it looks like all of our denominators are going to become 2BC, which is what we want. Now let's just check the numerators and make sure we don't mess them up. What's going to be the new numerator of the ratio on the left? 8C. Okay. How about the new middle numerator? 2B, obviously. And the last numerator? Yeah, BC. Okay. And pay attention to your signs in there. Don't lose those if you want your addition and your subtraction. Okay, that's a easy way to mess up a problem right there, losing your addition and subtraction. Okay, double checking the denominator one last time. Yep, it's all 2B's. 2BCs, so if they're all 2BCs, there is no reason for this to be written as 3 different fractions. It should be combined into 1. Okay, so just cramming all of the stuff into one numerator. Okay. Take one last look at the problem and see if there's any one term that all 4 of these terms can give up at the same time. Okay, and typically what I do is I look at it from a number standpoint. Is there any one number that I can get out of an 8 and a 2 and a 1 and a 2? If that guy's a 1, it doesn't have anything to give up. Okay, so it's not giving up any numbers. I got some C's. Do all the terms have a C? No, that center one doesn't in the numerator. Okay, I got some B's. Does everybody have a B? No, that term doesn't have a B. So it's just numbers and B's and C's, and not all 4 terms can give up either a number or a B or a C all at the same time. So this is as simple as this is going to get. Okay, getting it so far? Now refresh our memories. What happens when we end up with rational expressions and then they don't give us a fraction? We got some fractions, and then in other spaces we don't have fractions. What do you do now? Yeah, everything's a fraction, whether they write it down as a fraction or not. Let's turn it into a fraction. Probably the best first step to do so that you don't cause yourself any confusion or accidentally overlook anything. And then simply proceed to go through the problem like you normally would. Okay, what do you think about a common denominator this time? So you remember, we're trying to figure out, we want to be able to either leave things alone or increase them in order to become a common denominator for all of the terms. Okay, so here I've got a c cubed. Can I make this c squared become a c cubed? Do we know a way that we could knock that exponent up 1? How about the first law of exponents? If I were to multiply this denominator by another c, what would happen? We'd kick it up to c cubed, wouldn't it? Okay, so I can make that middle denominator become a c cubed. Can I make this denominator become a c cubed? Can I take it and multiply it by c cubed? That would kick it up there. Okay. When you get denominators where it's kind of trying to be the same variable over and over again, just with different exponents, that's fine. Just look at your laws of exponents. Okay. Ask yourself which law or what can I do to allow those denominators to kick up. Okay. So let's have a look at what's going to happen here. What am I going to have to do to the first ratio so that its denominator can be c cubed? Nothing, right? It's already c cubed. Okay, it is possible that you may not have to mess with a particular ratio in order to get its denominator to do whatever it is you're wanting it to do. In this case, the first ratio is good. Second ratio, what did we say? How are you going to get this c squared to become a c cubed? Multiply it by another c. Okay. And this denominator over here on the right side, what are we going to have to do to get that guy to become a c cubed? Multiply it by c cubed. Okay, these are just the laws of exponents. When two c's are multiplying together, their exponents will add up. Okay, first ratio was left alone. Second ratio, c to the first over c to the first. Say last ratio, c cubed over c cubed. Okay, it's going to make our denominators all become c cubed, which is good. Okay, what about our numerators? This one didn't get messed with, so it's good. Okay. What's this new numerator going to be in the center? 4 times c will be 4c. Last numerator, 6c cubed. Okay, all of the numerators denominators are all the same now. Okay, there's no reason for them to be apart like that. So we're going to put them all into one numerator. Okay. Last thing we do is have a look at the problem and see, do all of these terms that are in this ratio, do they all have something they can give up? Okay, well, let's look at the numbers, look at the coefficients. 1, 4, 6, and 1. Well, again, 1s aren't going to be able to give up anything, so we're not going to be reducing any coefficients. Okay, how about c? Do all the terms have a c? Yeah, hey, all the terms do have a c. Okay, so that means we might be able to take a c away from it. But can you see anything else we might be able to do first? Yeah, yeah. Look at this numerator. How does it start off? Here is a c to the first. And in the middle term, more c to the firsts. Anybody think of a reason that those two terms ought to be written separately like that? You have a c to the first. You have 4c to the first. How many c to the first are there? There are 5 of them. 1 of them and 4 more is 5. No reason for those guys to be written separately like that. Okay. And again, kind of returning to what we were saying here a moment ago, all of these terms have a c that they can give up. So we can take away a c from all 3 terms all at the same time and then write down what's left. So if we take away a c from this first term in the numerator, what are you going to end up with? 5. The minus will still be there. 6c cubed. If you take away a c from that, what are you going to end up with? 6c squared. Okay, and in the denominator, c cubed will become c squared if we take away a c from it. And then you can look at it one last time and go, did I get everything? Is there anything else that I can get out of all 3 of those terms at the same time? I don't see anything. Okay. But again, always keep an eye out for it to be reduced. If you don't reduce it, it's not incorrect. That's just not the answers that you're going to see. Okay. If this were a multiple choice test, you would not see, okay, this answer right here, this c plus 4c minus 6c cubed over c cubed. That wouldn't be an answer choice. You wouldn't see 5c minus 6c cubed over c cubed. That wouldn't be an answer choice either. But this bottom one would be. Okay, so we always want to just get in the habit of reducing so we understand exactly how things are supposed to reduce. Okay, here's one problem. Okay, let's take a couple of moments and have a look at it, see if we can't figure it out. Jot it down on your paper real quick and give it a try. 5 over 4a minus 2 over 3b. I'll give you a couple of moments of head start, and then I'll start working through the problem and see if I can't catch up to you. Hopefully you were able to come to the decision that the common denominator could be something like 12ab. The two coefficients, 4 and 3. Okay, when you start increasing them by multiplying, the smallest number that a 4 and a 3 will both become is a 12. We've got an a and we've got a b in our denominator, so 12ab is probably our denominator. So what we need to do is figure out what do we need to multiply our values by so that our denominators can become common. Looks to me like in order for a 4a on the left to become a 12ab, it needs to multiply by a 3 and by a b. And whatever we do to the denominator, we must do to the numerator to keep the fraction true. On the right-hand side, in order for a 3b to become a 12a, b, okay, we need a 4, and we need an a to get to 12ab, and whatever we do to the denominator, we have to do to the numerator also to keep the fraction true. Okay, so from there, we ought to be able to start to simplify some stuff, join our ratios together. Simplifying numerators and denominators in each of the sides of this subtraction problem. It looks like 15b over 12ab minus 8a over 12ab. Double check, make sure your denominators are common, which they are. Now we ought to be able to combine them all into one fraction over 12ab. Oops, I put 15a, it should have been 15b. The final thing to check would be to look at these three terms that are in this ratio and ask ourselves if there is any one thing that can be taken away from all three terms at the same time. Pretty easy to see that on the A's and the B's, okay, each term or the terms, at least one of the three terms is missing an A or a B, so we're not going to be able to take any A's or B's away. Okay, so the last thing we could really think about is possibly these coefficients. We've got a 15, we've got an 8, we've got a 12. Thinking of the factors of 15 and 8 and 12, is there any one value that you can think of that we can steal from a 15 and an 8 and a 12 all at the same time? 15 is 3 times 5. 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. They have any factors in common between the three of them? No, doesn't look like it. Okay, so that's going to be your ratio. That's as simple as we can get it. Just got one more for you. Want to make sure that we understand this. Finding common denominators is not one of our strengths, so I want to make sure that we know it before I turn you loose. So here we have a three-term rational expression, p over 4 minus a over 2 plus c over b. Let's see if we can't simplify this down into one term. Looks like the lowest common denominator you could probably come up with is a 4b. If you don't come up with the lowest common denominator, that's fine. As long as you get a common denominator, your problem will work out. But if you don't come up with the lowest common denominator, then that just guarantees you that later on in the problem, you're going to have to reduce somewhere between the numerator and the denominator. Okay, so if you didn't come up with 4b, like let's say you came up with 8b or 20b or something like that, you could still work the problem. You just have to reduce later on. So now, what do we have to multiply each fraction by in order to obtain this 4b? Ratio on the left looks like it needs a b in order to become a 4b. Ratio in the middle looks like it needs 2 and a b to become a 4b. And the ratio on the right looks like it needs a 4 in order to become a 4b. Okay. From there, you want to combine your ratios in between all this addition and subtraction. Okay, simplify this multiplication on the left, multiplication in the middle, multiplication on the right, and see what those terms end up looking like. Okay, it looks like PB or BP, if you put it in alphabetical order, over 4B minus 2A, B over 4B, plus 4C over 4B. Okay, double check, make sure your denominators are all common so that you can then combine it all into one ratio. Okay, there's that BP on the left, minus 2AB in the center, and 4C in that trail term. Okay. Last thing we want to do is check and make sure that these terms don't have anything in common that they can all give up. We've got a coefficient of 1 on our lead term right there, so if you got any coefficient that's a 1, you're not going to be able to reduce the coefficients at all. Okay, I've got some b's. Let's look around and see if all the terms have a b to give up. Now the trail term in the numerator doesn't have a b. We got some p's. Okay, well the center term in the numerator doesn't have a p to give up. We got some a's, but the lead term doesn't have an a. We got c's, but we don't, we don't have c's all over the place. Looks like we're about as simple as we can get it. Okay, so that is as ugly as it is. That's our answer. All right, well, that's pretty much it. You've got some practice problems that go along with this. Tomorrow will be probably just nothing but a review, and I don't plan on going back over the material a whole lot. We'll run back over the laws of exponents and the basic guidelines, but that won't take us any more than about 10 minutes for me to just say it again. So I will probably put together some type of a review worksheet, practice problems that you can take a look at to see if, in fact, you are ready for your Unit 8 test on Thursday. So that is it. Let's get to the worksheet.